Hello, this is Mrs. Taylor, and I'm going to give you a mini lesson in logarithms. And I'm calling it a mini lesson because it's really important that you understand this is just a quick refresher in logarithms coming from the assumption that you have already learned this material. And so I'm going to move through this very quickly and just touch on some quick reminders that will help you in the calculus class. So remember that if I have an exponential, a to the x equals y, the a is the base, the x would be what the logarithm would equal, and the y would be what you're taking the log of. So this is just a little graphic here to help you keep all that organized. So if I have log base a of y equals x, I can rewrite it as a to the x equals y, and then vice versa. And this little graphic and majority of this information is from this really helpful website, www.mathisfun.com, and it basically looks like this, and if you open up the website you'll see a lot of these graphics and explanations are here as well. So if the video moves too quickly or you need further explanation, this is a great website to visit. So the properties of logarithms, don't forget how to expand and condense. So if I am taking the log of a product, I would separate it through addition, expand it through addition. If I am dividing m divided by n, I would expand using subtraction. Remember that the exponent of your variable or your number, whatever is here in parentheses, can be brought out front of the logarithm. So if I have 1 over a number or a variable, remember that's the same as writing that variable to the negative exponent, and it would bring the negative out front. So that's what this property is. And then this property just shows exactly what I just said, where if you have an exponent, you can bring it out in front of the logarithm. And so remember that if there is no a written, no constant here at the base, remember that means that we have a base of 10. Just like if you don't have an exponent, it's understood to be 1. Well, in logarithms, if there's no base written here, it's understood to be 10. And so if I had log of x equals y, then that means that there's a base of 10, and using this rule here, I could rewrite it as 10 to the y equals x. And just one more time, just to drive the point home on this property, if I had something that looked like this, log base a of x squared, please don't forget to rewrite it as 2 times log base a to the x. Especially in this class with simplification, it's going to make a huge difference. So here's just a set of problems to help test your knowledge with the logarithms. They want you to write them in exponential form. So that means take the base, make it a base, take what the logarithm equals, make it the exponent. Using the graphic here as a helpful tool. What I would do is I would pause this video, jot some of these down, work them out, and then hit play, and the answers will be there. And so these are the solutions. Log base 3 of x equals 9 can also be written in exponential form as x equals 3 to the 9th. And then you can actually evaluate 3 to the 9th either in your head if you wanted to multiply 3 by itself 9 times, or using your calculator. So you can actually find out what x equals. And then like B, I could evaluate log base 2 of 8 using my calculator and find out what x equals there as well. This is a set of problems where you just work backwards. So again, if you'd like to pause the video, work through some of these, make sure you understand how to take an exponential function and rewrite it as a logarithm. Pause the video now. And then these would be the solutions to those, writing them in logarithm form. So y equals 3 to the 4th. The 3 is your base, so it would be log base 3. Whatever it equals the y is going to be what you're taking the logarithm of, and then that 4, that exponent, is what the logarithm entirely equals. So this is just one more set of problems to practice a skill that you should already have before you take this course. It's solving logarithms. So you, excuse me, you rewrite the logarithm in exponential form, and then it helps you to solve the equation. So in other words, here for a, I could rewrite this as 3 to the 4th equals x, and then I would just have to evaluate 3 to the 4th. So if you'd like to try some of these, again, pause the video, and then the answers will appear when you hit play. So here are the solutions on A through F, and if you have any questions about how these solutions were arrived at, then please ask in class tomorrow. Alright, so this problem set is just simplifying, so taking some expressions and using what you know about the logarithm properties to simplify the following. So for A, log base 2 of x times y minus log base 2 of x squared. Remember, if you have a product, you can expand it to log base 2 of x plus log base 2 of y. And then don't forget that if you have an exponent, you can bring that 2 out front. And then again, here's this minus sign, so that means everything here will be divided by everything here. So one more time, press pause, work through some of these, see if you can get them, and then when you hit play, I'll put the answers up. So yet again, this is a set of problems that if you're unsure how they arrived at the solution they did, please circle those problems and ask me to work them out in class. So now let's move on to natural logarithms. Those are logarithms with the base of e. E is named so after Euler. It's his magic number. He discovered the significance of e, and it is approximately 2.72. That's rounded. It is an irrational number, so it's a non-repeating, non-terminating decimal. Therefore, we can never really write out the entire number. But when you work with e as the base, you get what we call natural log. So instead of writing it log base e of x, it's written natural log of x, or ln of x. And then our base is e, so we would write e to the x in exponential form. A couple of really important rules to be aware of is if you take the natural log of e to the x, they are inverse functions. So the natural log and the e cancel, and you're left with x. And then if you raise natural log of x as an exponent of e, again the same thing happens. The e and the natural log cancel, and you're left with x. They are inverse functions. And down here is the website to access the specific information on the Math is Fun website. Because e is an irrational number, a lot of the evaluating you'll do with e or natural log is using your calculator. So this is just strictly punching things in your calculator and evaluating. You can pause the video, and when you hit play, the solutions will be there just like before. And in these solutions, please be mindful that this particular activity did not require students to round to 3 decimal places, but the College Board's policy as far as the AP exam is that they want you to round to 3 places. So instead of writing 0.34, you'd need to round to the 3rd decimal, the 1000th place. Here is some simplifying practice. The first one is with logarithms, and the rest is using natural logs and e's. Keep in mind, for example, with e, we have natural log of e squared, so remember that rule that natural log and e are inverses. And then also for c, keep in mind that e and e, those are like bases, so you can use the exponent rules to simplify that one. Yet again, pause the video, and then once you hit play, the solutions will be there. So here are the solutions for A through F. Keep in mind that for F, e squared times natural log of e cubed, that's a product, so you could separate it using addition. You'd have natural log of e squared plus natural log of e cubed, and then the natural log of e squared plus the natural log of e cubed. And so that would help you simplify to F. Once you expand it, you have natural log of e squared, natural log of e cancels, and you're left with the 2. And then here you would work from the inside out. So natural log of e cubed the natural log and the e again would cancel, and you'd be left with natural log of 3. So that's how you would simplify those. One more set of problems. Here we are solving for x, and again it's just a matter of either writing, if it's in logarithmic form, you'd write it in exponential to solve, and then if it's in exponential, you write it in logarithmic to solve. And then for some of these, you may have to use your calculator to evaluate or to finish solving. But pause the video, and then this is the pattern with this video. Hit play, and the answers will be there. And there are the solutions. So hopefully you got all those correct. If you did not, again, circle what you're confused about and ask in class. The last thing for this video is just a reminder on the change of base formula. If you look at your calculator, the only logarithm button on the calculator that you can hit quickly is the log with the base 10. So if you have that and you need to evaluate a logarithm, just keep in mind that you take log of, and of course you'd use 10 here as your common base, because that's the only one your calculator has to do quickly. So you would take log of the x over log of the a in your calculator, and you'd be able to evaluate. Also remember that with logarithms, you can also rewrite it as natural log, because those have the same base, e and e. So it would be the same thing as this formula. It's just using e as your base, which makes it natural log. So just keep that in mind as well. And again, this is the website that can give you all this information about exponents and logarithms.